Sanjeev Sir, you
Wonderful.
are next. I
Thank
take this
you.
opportunity to welcome you again. It's always a delight to have you. Even while following you on LinkedIn, look at all the amazing innovations that you are doing. It's always exciting to see, and in fact, it encourages us to think out of the box. The kind of ideas you bring in, the way you blend the platforms. Like it's not about just learning a single technology. It's about seeing a real life use case, putting it to work using the latest tech stack, and that's and how you weave those together. It's always exciting to know that. Thank you so much
Very,
for helping out the community there. Pouring in these great sessions and ideas, and we'd like to welcome you again today for another exciting session. Thank you for
very,
joining
very,
us today.
very kind of you, Abhinav. Extremely kind words. Truly honored. And this is my favorite community because folks are so amazing and yet so grounded and humble, And I'm looking at both you guys, Dhruvin and you, and then you do such great work and yet so humble and grounded. It's fantastic, And we have Aro as well, who is amazing, amazing. What a lovely, lovely gentleman, very kind, outreach. It inspires people like us, right, to do more. When you meet people like that. So it's absolutely fantastic to be part of a group of people who are like-minded. So let me share my screen with you. I really don't have any slides, so it's going to be literally hands-on for the most part. But let me frame the discussion. And to be honest with you, I had thought about doing, the preventative maintenance thing with the drone and then the Copilot Studio and all that from the last post. But something that Clavin said yesterday made me change my mind a little bit. So sorry to change the topics a little bit. Is as we were talking towards the end, we said, what's his name? I forget his name. The NVIDIA CEO. He basically said, hey, we are going to go away from coding. If there's anything that the Copilot has actually done, it has influenced me to code more, actually, and do a lot more coding that I'd ever done before, right? So it is the opposite effect, if you will. And what I thought I'd do is go a little deeper, peel the onion behind the scenes when it comes to the components that go into preventative maintenance and some of the more finer aspects, if you will, like, shine a spotlight on it, right? So the problem statement here is of the many things you do in preventative maintenance, one of the things you do is controlling devices. Now, it could be any device. It could actually be, for sustainability, it could be telemetry from, temperature and humidity meters that are coming in. It could be robots that, or automated guided vehicles that actually go on the shop floor that you're controlling. Anything along those lines, basically, you're talking to devices bidirectionally. You're talking to the device is talking back to you, right? So my focus here is the communication back from the device is okay. You have IoT Hub, IoT Central that does that wonderfully and then spits out the data ever so often. That is fine. But my interest is actually in me communicating to the actual device, right? And the idea here is to minimize the round trip time. I press a button to start a motor, let us say, in my Power Apps. It starts a motor, and then there is a callback function that gives me back the time, right? So I want to make sure that that time, between the time that I actually click and I get the response back saying, hey, look, there is proof of execution, I want to minimize it while we use the cloud. And you cut my arm off, I bleed Microsoft, so using Microsoft Cloud, right? So that's the problem statement. And with this in mind, let me give you a little bit of a history, if you will, of what these times used to take for me about 6 years ago. I used to do directly from the PC using serial communication to the device. So it was almost instantaneous. I'll show you that. And then when I got started with the cloud, I'll show you how much time it used to take to start to talk to the device. Okay. So this goes to a post on LinkedIn. So it is right here. And then let me just showcase to you. So basically, it has an engine here. So this is a single cylinder, engine. It has got a spark plug. So what happens is, and it's got a starter motor here. Okay. So the spark plug basically fires. So there's a tiny little bit of a fire inside the cylinder. The fuel comes in. When the fuel and the air and then the spark plug is there, obviously there's going to be combustion, and then the motor basically turns the crank and then the engine starts, right? So in order for us to actually start this engine, we need to first, turn on the, what do you call that? The spark plug. And then you press this button to turn on the motor, and the motor turns on the engine, right? So that's the story. So I'm going to move forward here. And this is where I'm actually, so let us do a count, right? This is where I'm clicking on the spark plug to start. So we'll count from here. So 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000, 7, 1,000, 8, 1,000, 9, 1,000, 1,000. So it literally took 11 seconds for the motor to start. You see? So that to me is the sort of the latency, if you will, right? Is what I actually started with, right? And the solution here was using Power Apps in the front end. So when I basically click that button for the spark plug or for starting the motor, the they're essentially values, right? I mean, it could be like 0 to 255 units, like, digital units. And that corresponds to some voltage. And then I'm actually sending it to the spark plug and the motor, right? So those values, I would store it in Dataverse and then maybe in SharePoint to make it simpler, right? So I would actually store it there first. Then what would happen is there would be a Azure Logic app that would pick up this particular value and throw it up on a web link, basically, right? Then you would use a HTTP premium connector in Power Apps that would go to the Logic app, the URL. It would grab those values, and then it would actually send it to, through IoT Hub, it would send it to the code, right? And the code would actually run it. So you can see how much time is actually spent in basically saving the data to the database and then retrieving it in your Power Apps. And remember, you have to do filtering in your Power Automate for the simple reason you're just overwriting the first row over and over again, right, with the values. So you have to filter that. Then you pull the value, spit it out to your, URL. From there, it actually goes to, your, how do you say, IoT Hub, and then from IoT Hub over to the device. So there are a lot of stops around here, and it used to take 11 to 15 seconds, depending on what you're doing. So that is essentially the first problem, right? So if I go up here, that is the problem statement, and this is the history of 16 seconds. So I'm going to actually mark this now, right? So now, if you look at what I literally did a post, 3 days ago. So I'm going to show you that as well. I'll put that down in the link because I'm going to be doing a detailed YouTube video on this. I'll mark it in the comments. So I'll just copy this, paste here, copy this link here and paste in the chat window. The point here is I'll walk you through what the time looks like right now. So remember the 11 seconds. And remember what this is actually doing, right? So if I play this, and then I think I'm going to go to a place where the motor is maybe stopped. Let me just see. The motor is actually running right now. See, the motor is actually stopped right now, right? So when I move this slider here, the motor actually starts. I'm doing this instantaneously. You see, I've stopped. Whoops. Let me go back. So I'm literally actually moving this up and down, and then it is actually running the motor. I mean, in like milliseconds, right? So, and I'll show you this in real life. I know the video that can be a little bit of a lag and things like that when you do the recording, but then I'll show you this in real life in a minute or so, right? So when you do this, I basically did a collection of all the counts. So I wanted about 60 odd data points because I want to be statistically significant. And then I counted the times that it takes to send this command over to the motor, right? And these are in milliseconds. So when I took all the times here, I ignored the first one because at the very start it's lazy. After that, it gets very quick. Within the next command, it gets very quick. So I just ignored the first command. So over here, if I do the normal distribution, you do a histogram, the average is around 500 milliseconds, so half a second, compared to the 11 seconds. This is half a second. That's a significant reduction in time. And then the standard deviation is around 100. So, you take 3 sigma on either side. So it could be anywhere between 200 milliseconds to about 800 milliseconds. You follow? So that is the current state. Now, kindly do remember that I'm actually doing a collection while on change of the slider, I'm doing a collection, I'm collecting the times. So there is a delay in collecting the data points as well in the collection. If I ignore this, maybe I could get down even further. There are a couple of things I could also do to get it down to maybe like 300 milliseconds or 200 milliseconds on the average, right? Now, you can just imagine the significant difference between what happened like 5 years ago with like 11 seconds to this one. So that is kind of the story. It is a process of continuous improvement and then keep testing it. As you folks saw just a few days ago, Satya announced the quantum computing chip, very early stages, but that could take this down to nanoseconds as an example, right? So why do we care? Why do we care about doing this? The whole idea here is, and if I could, yeah, the whole idea here is when you are doing preventative maintenance, and let us say I have a firefighting drone or something like that. Yesterday, I would actually have to use physical forms like a controller to control the drone, right? Because I'm a little scared about like latency and things going wrong and so on and so forth. In today's world, if this is going to give me millisecond responses, well, guess what? I could actually run the drone directly from my Power App, which I've done before. But the thing is, I could build out a huge drone, and then do agriculture, firefighting. You can run it in a warehouse, so on and so forth, in order for you to do that, preventative maintenance or like, some solution around those lines. So that's why it really matters, right? So we have gone through history, we have gone through the current state, and then as you can see in the current state, it is 500 milliseconds, right? Now let us actually see my device is actually connected and I have a camera here to show you. It's a little upside down, so kindly ignore it for a second. And I'm going to basically bring the code in as well. Not this one. I didn't jump the gun a little bit. Let me actually go to my Arduino one. I don't know, maybe I closed it, right? So let me just open this code up. And this code does not have the cloud, right? It doesn't have the cloud. Setting, okay, restart, whatever. We'll give it a second. Okay, so this code here does not have the cloud. So this is the fastest you can actually get, right? So I've got a board here. This board is called ESP32C6. It's the shortest, the smallest, tiniest form factor that you can actually get with the ESP board. And the exciting thing about this is I could actually, I don't know if I have a coin here to give you an idea. Maybe I do, I don't. Let me just see if I have a coin. Kindly give me a second. Where is that? Okay, what coin is this? This is a 50-cent coin. I'm gonna actually put this right next to this guy here. You see, it is actually smaller than a 50-cent coin, right? It is so tiny, this form factor of this guy. So that board has got it's got a microprocessor and it's got many different outputs. It's just like your Arduino, except that it's miniature. And it's got like many different outputs. And these outputs you can actually send out to control this motor, right? And then there's a motor driver. Typically, the motor drivers are actually huge, but this one's miniature as well. This one's tiny. So essentially what you could do is you could use this combination in a small little robot that crawls around like, what do you call your production floor, especially if you're doing pharmaceutical production and so on and so forth. You're not going to have massive production floors. They'll, you can set that in and then let it crawl around and then, do a bunch of things, right? I mean, we'll get into those kind of, scenarios later. But the point is, this code is actually running right now. So what does this code do? Basically, it energizes, these pins. There are a couple of these pins. So it energizes those pins and then it passes pulses, right? So when it passes pulses over here, you see, it is basically passing the pulse into this one, and this one and this one are your positive and negative. And then you energize this one, you actually put this on low, and then you send the pulse value and it actually runs the motor, right? So it goes from 0 to 255. 0 is 0 volts, 255 is the, 6 volts or something that goes into the motor. So if I go in and actually say half of it, let us say half of 255 is around 125. If I say 125, the motor actually spins, right? And then it spins for like a second or so. And you see that the time here, the process time is 16 microseconds. You follow me? So let me run this again. If I do 100, you see it is 16 microseconds. In within 16 microseconds, 10 to the power minus 6, the command goes through to the motor. It's almost instantaneous, right? Now, compare that. This is the absolute nirvana state. This is what we really want, right? This is what we desire, instantaneous communication to the device, right? Whereas when I went to my LinkedIn over here and I showed you this one took 500 milliseconds. It's an order of magnitude, right? Where is 16 microseconds and where is 500 milliseconds? So that is order of magnitude, right? So the idea is to find a combination of hardware and then software within Azure and let us say an interface in Power Apps to keep minimizing the times from the 11 seconds. 11 seconds, that seems like an eternity, right? It's like you might as well be walking in suspended animation. You follow me? Slowly walking around. So like a grandfather, So you have 11 seconds grandfather. You have Sanjeev, who is 52, who can actually go to about 500 milliseconds, and Sanjeev's son Ari, who is actually able to run in like 16 milliseconds. So that is the goal, right? So if I were to go ahead and unpack this, we'll run this. I will show you the code, and then we'll actually run it. We'll compile it and we'll build it and run it. So if I were to go to the Excel here, let us look at the setup of the current state, right? So we went through this pure on-prem over here. So let us look at the current state of the architecture. It all starts with your IoT setup, right? So I go over to my IoT hub here. So where's my Azure portal? I don't want this. I'm going to cancel and then I'm going to go to my IoT hub, right? So if I go to my IoT hub here, so I basically have devices. So, you can actually set up these virtual devices just like the device you have. I've actually given it a name. I see, device IoT hub. I normally use what is called as IoT Central. I'll walk you through that later. But for now, following along the agenda, this IoT hub is what I just go in, add a device. Once I basically add a device, it basically gives me the connection strings, right? For me to go actually connect, it gives me the primary key and the primary connection string, which I can actually use either in my .NET or in my Python. I can use this to connect to it, right? Then what I could do is I could actually go to what is called as a direct method. I can add the JSON here. So what do I need to run this motor? So if I go back to this code here, essentially I need two things. I need the value, right? And what is not here is the direction of rotation as well. I could go in and add another one that, variable to rotate the motor, forwards or backwards. How do I do that? If I change this to low and change this to high, I swap the polarization of the pins, and then it becomes either clockwise or anti-clockwise, right? So if I add a variable and then if I make that how do you say, dynamic, I'll be able to change the direction of the motor, okay? So, I mean, this is all ancient stuff, nothing exotic here, nothing terribly new, except that I'll actually be doing that from here. So if I go to my notepad here, I think my notepad is somewhere here, and, so, over here, I've got my code, and then the what do you call the JSON is here. I paste this one. I have my device ID, and then I give it a name, for my method. And the reason why I have method names is because I may be controlling many different items within my device ID. So I'll have like, different names for the methods, right? So this is a direct method that sends the command over to the actual code, right? So here I quote the device ID, I quote the pulse width modulation value between 0 and 255, and then I quote the direction, and then it actually runs, right? So this is the fundamental way through the GUI within your Azure to send the code to the setup. But clearly, your end users who are either engineering managers or not managers, engineering technicians who are on the floor or something like that, they won't be doing this, right? I mean, you can't expect them to do this. But what we can actually do is package this and then let Power Apps actually do that, right? So if I go here to my Excel now, so IoT setup, you've actually seen this. And in this IoT setup, basically in your device, it goes in, it actually gives you a response back. So there's a callback function. So it comes in and actually says, hey, look, it succeeded, 200, and here's your value, and so on and so forth. So once you invoke the method, there is a callback as well. So you know that there's proof of execution, right? So if I have this, so if I go back here, if I have this IoT setup, now let us go to the other end, right? We'll go to the other end over here and then look at the Power Apps setup, right? So if I go up to my Power Apps, here I have my app. And then if I go to the slider, and then I'll refresh this, looks like, because if I were to go to on change, yeah, I need to refresh it. I, you know, had it open since last night and it's a little stale. The session's a little stale. So let's actually open this. And by the way, I'll be doing a full-blown hour and a half YouTube video on this, on including, the points of the code, so on and so forth. So I'll paste it in the LinkedIn video itself, right? Because my goal is to attract, developers talking to electromechanical engineers like me, and people like electromechanical people like me talking to you guys. So the goal is to actually do the marriage, right? So if I go to, I'll look at the chat shortly, folk. Okay, so kindly give me a second, otherwise I may lose my flow here. So if I were to go to the on change property, what I'm actually doing is, first of all, I'm actually getting the time in milliseconds. So that is the start time when I click the slider, or like when I move the slider. Then what I'm doing is I have a custom connector. So in my custom connector, I have the value, the slider value that goes from 0 to 255. Then basically I have the value of the direction itself, whether it's clockwise or anti-clockwise, and then the device ID. The device ID I've actually, like, I don't know, I may have hidden it over here. It's on top over here, right? So I send the device ID, the same 3 JSON points that you saw in IoT Hub. I'm actually passing this, and then I have a response back, and I'm putting the response back into a variable here, right? And then at the same time, I'm capturing the end time. So when I actually subtract out the start time and the end time, I get the full response time, right? And I collect that in this particular, collection. And then I do whatever, the normal distribution, the histogram that I have to do. I do that in Excel, connect to, SharePoint, and grab the data, right? So this is the Power Apps side of the house. So if I go back here, so this is the Power Apps setup. Then let us look at the client-side code. So obviously, when you do the IoT Hub, and then you have the code that you just saw, that is on-prem, but I'll show you the equivalent, that runs on the actual device with the API. So there is an equivalent, that's the server-side code. So likewise, there's a client-side code that actually sends the value over to IoT Hub, right? So if I look at the client-side code over here, and oh God, what happened to that? Kindly give me a second. Visual Studio Code, right? So essentially, if you look at the client-side code, what it's basically, and it's got the, I don't care, it's got the, what do you call the connection string, this is dummy. I'll be doing hundreds of these. I'll probably delete it the moment we actually so it doesn't matter, right? So essentially what I'm doing over here is I am basically, doing a HTTP trigger, right? And then in this trigger, I'm actually sending the device ID. I'm sending the value and I'm actually sending the direction of rotation, right? So the high, low, low, high to actually do clockwise and anti-clockwise. I'm actually sending it through this, body here, request body. And then the rest of it is a classic, Azure function. And this you would have seen 100 times. So I'm not going to go over that component of it. But then this component here is where I'm actually sending the data. It's also an anonymous post. There is no authentication in this particular case. It's an anonymous post, right? And then you can beautify this thing up, right? And kindly note that my viewpoint is from a person, a design engineer who's actually sitting in front of this. Like if I back up a little bit, when I started my career back in '96, I started as a design engineer for a Japanese company. I used to design for an automotive company the speedometers and the tachometers, like the instrument panel, right? So there used to be a chip that is right. It's a computer. It's the brains of the car. So the computer is right on your device, and then it controls the LEDs and it controls the motor. So when I used to test the motors for torque and like for, current and so on and so forth, the devices used to be sitting on my PC, and I used to actually use code like this to actually control it, except it was now all on premise. Once I had my whole prototype done and I was satisfied with the performance, then I would hand it off to the embedded engineers for them to actually package it, and they would add like logging, so on and so forth, other things that they're interested in. I knew from my side that it would actually from a physics and a science standpoint would work. So that component of the code I did, and I handed off to the embedded software guys to burn the code into the EEPROM and then into the actual chips, right? So this is doing that. Essentially, this this C sharp, function basically carries these values from my Power App into the device, right? So if I were to go back here, this is essentially, I'll be doing a deep dive on YouTube. So, kindly, and I'll do it tonight, once the kids go to bed, I'll actually do that. So you have client side code. Now we send this, it goes online, isn't it? Basically, you have your Azure function. And if I were to go to the Azure function over here, so this is IoT Hub and this is my Azure function, right? So the code, once I package it up, and then in my case I'm very poor, so I actually use the command line and then I publish it to my Azure. Okay, what I mean is, if I were to go to, let us say, OneNote over here, I might have, I'll do it in that video. I'll show you where is this. I might have it somewhere down here. This it's been ages since I touched some of, yeah, this one, right? So essentially creating the function. So basically I have a storage account, right? I'll have a storage account over here. Then I will have my consumption plan. And then this is actually the Python function, but the C# one is essentially, the .NET one is essentially the same thing, right? So you have your runtime consumption plan, you have your resource group, and then you have a storage account, and then you actually create this function right from your command line. You could do it many different ways, PowerShell, whatnot, but for me, command line is good enough. It's simple, easy. My focus is actually on the time, right? Not so much on the mechanics of like how I create the function. So once I get to the function over here, then I could actually pass the same exact, JSON over here, and it will run, right? Why will it run? Because it is sending the value to IoT Hub, and IoT Hub is sending it to the actual code. You follow me, right? So this is my function. So I'm gonna go ahead and write. So once I have my function, the next step is to actually package it within my custom connector, right? So I go to my custom connector. So I have basically my function. So this guy gives me, if I were to go back here, where's my function? So if I were to go back here and go to my function URL, it gives me my, how do you say, the URI. And then I take this, I actually embed this in my custom connector. And then when I go to the definition, and then when I go to the request JSON, I basically post that same exact JSON code into it as an example. Now I leave the default response to be the default. I don't actually indicate anything. And there is a conversation to be had on this one. I'll come to that shortly. And then, I can, if I go to test over here, I say raw body, and I can paste my JSON over here, and it'll run, right? So this is passing it to your Azure function. The Azure function is actually passing it to your IoT hub, and that's actually like running the code. You follow me? So that's the whole 9 yards, right? It's what's happening here. So let me go back here. So that is basically the custom connector, right? So if I were to go to my Arduino, and I could do this in C# as well, you just need to download the libraries. That's about it, right? So kindly give me a second. I'm going to reshare my screen for the simple reason this guy is hidden. Stop sharing. I'm going to make this bigger and now share my screen. In fact, actually, I'll open the sketch as well, right? Where was that? This guy. Open it. I think this is it. I've been playing around with it for quite some time. So I'm going to close the other code and reshare my screen. Okay, so kindly give me a second. So this guy over here is basically the code that actually sits on the device, right? This actually sits on the device. So if I go to tools over here, the sketch, let me just see. Whoops, what did I do? I didn't want to do that. I didn't want to close it. Kindly give me a second. Great. And if I go to my serial monitor here, okay. So let us actually verify this code. We'll compile this. So it is compiling the sketch. Takes a bit of time. And in the meanwhile, while this is doing it, let me see what folks had as a question in how many connections we can add in Power Apps. Plenty. I mean, I could, at the same time that I'm actually adding, what do you call your custom connector, I could actually add in a Power Automate connection. I could add in data source connections. I'm not particularly sure as to exactly the number of connections. I'm not sure. I'll call on our good friend Dhruvan, maybe. Dhruvan, do you know, sir, how many connections one could add in any one instance? I'm not, hey, I don't know. Let me just ask my good friend Copilot. Where's my Copilot? Go to office.com. Right. Dhruvan, do you know, sir? Because I don't want to move away from the code. It did. So let me burn the code to the database. Kindly give me a second. Good question. So let me upload this. Okay. So this is getting uploaded to the device right now. And you will see here that essentially it is the same code as before, right? It is the same code as before. You see I'm energizing, the same pins. But then what I'm doing in this instance is I'm actually using so many additional layers, right? So first of all, I need to actually get my Wi-Fi, right? So I have my, variables to actually get my Wi-Fi. And then once I have my Wi-Fi, I need to actually go into what is called as MQTT, which is the broker that actually, does the conversation between the publisher and the subscriber in the IoT hub, right? So I need to go in and actually, like, once I connect to my Wi-Fi, I need to go to my MQTT and then connect to MQTT and have my cases over here. Hey, when it's not connected, if there is an error, so on and so forth. So there's a little bit of error monitoring over here, performance monitoring. Once it actually goes away and connects to MQTT, and this is where it's actually doing the connection, it then basically goes in and says, okay, give me the name of your method, right? And if I scroll down here, this is the payload request. So here is my, you see, check if the method name is PWM, right? So it does a check for my method. It knows what my IoT hub name is up front because I would have connected to the IoT hub and then to MQTT. And then this goes away and then says, okay, here is your what do you call direct method name. And once it confirms that the direct method name is there, it goes and connects, and then it gets the payload, right? And once the payload comes in, I can actually, we can add as many connections as you wish. Thank you very much, sir. Let me just quickly, we will need to have a premium connector. Yeah, we'll get to that. So thank you very much, sir. So over here, we have gone in and then we have gotten the value, which is the pulse width value, the 0 to 255. And then we've got the clockwise and the anti-clockwise direction or whatever, right? And then it basically goes ahead and then it sends it just the same way the on-prem code did. Imagine the layers here, right? So at the end of the day, the code is the same. It basically energizes the pins high and low for direction. It sends the pulses in and the motor rotates, right? But then when I'm running this, I've got all this additional layers. So I have to do the Wi-Fi. I have to go to IoT Hub and connect it. Once I connect it, I have to message back so that I know that it has been connected. Then I have to go subscribe to MQTT. So there is that layer that I have to manage. And then finally, when I go in and actually pass the command, I need a callback function. Remember that I was telling you that response. So this is the response that I actually get if it runs, right? It goes away and says, hey, motor running clockwise, or no, it is not doing anything, blah, 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 right? And then it basically loop it. You loop through it because it keeps like looking for the data, and then it writes it to the database. So that is to the board, right? So that is essentially the server side of the code. And it's got like subroutines over here. So I'm an old guy, I'm 52 years old, sorry. So to me, these are subroutines and manifest files, right? So over here, I can actually go, and I'm not going to click on this because it's got my personal information on Wi-Fi, etc. So in the configuration file, it's got the connection strings, and then in the Wi-Fi configuration, it's got the Wi-Fi. So those are the two basic things that I need. And I go into my extensions over here, and I need two extensions. One, I actually need an extension for this particular board. So this board is called SHAO ESP32C6. You will see that in the YouTube video. So it is XIAO ESP32. So I need to get the board in over here, and then the library for the board. And I obviously need the Azure SDK. It used to be Azure IoT SDK before, but they have generalized it to the Azure SDK. And then from there, you can actually call the library in right up here, right? So you can include, the Wi-Fi, you can include MQTT, and then you have your Azure IoT. So this is the one that actually gives you the token. And then, for you guys, when you're in production monitoring performance of this, you will have the logger and so on and so forth, right? So these are all the libraries that you actually include. And then you also have your subroutines that you call, okay? So let me now play this whole thing, right? So we have the custom connector, right? And we have all these now, the server-side code, the client-side code, the Azure function, the custom connector, right? So now if I go to IoT Hub, and then where is my IoT Hub? I think it is right there. And then I'm going to do that. And then since the code has been burned to the, what do you call, the device, this should actually run if I invoke this because I've burned the code. There you go. So it is actually running, right? And it got back saying motor running clockwise. So what I'm going to do is I'm going to pass value of like 3, and it's going to basically stop, right? Because the pulses are too low, the voltage is too low for it to actually run, so it stops. So I know that my IoT Hub is actually like sending the commands over to the server-side code properly, right? So now I go to my function, my Azure function. I do the same exact thing, right? So I'm going to basically test run this. I'm going to say in the body of this, I'm going to send a value of 65 and run this, right? So there you go. So basically the package works okay. And the HTTP response here, and this is important, this response is actually coming in not basically as a full-blown JSON, but as a string inside the JSON, okay? The inside is not an object, it is actually a string, okay? So, and there's a reason for this. I'll tell you that later. Maybe you guys can actually help me, uncode that within Power Apps. I have been working around it. I did it a few times. I was like, hell with it. I'll just pass a text command, right? So I'm gonna stop this. So this should stop it. So there you go. Now I'll go to my custom connector, right? So, I've got my server-side code that is working. I've packaged that inside my function that is working. So now I'll actually go to my, what do you call this? The custom connector. So if I test operation over here, this goes away and runs it too. So it comes back and then says, hey, the response is 200. And then the body of the response is basically a text over here, right? So I go back in here and then I like stop this. Okay. So now I've got everything going. So I go over to my Power App, right? So in my Power App, if I were to play this Power App right now, and then I'm going to do that and put this guy in the center. And then, right up front, it is telling me, hey, Sanjeev, make sure that the function app is actually on, right? Because sometimes what I do is, as an obedient son, I go in and then where is my, I don't know, do you guys know how to hide this Teams thing? In Zoom, it is Control Shift Alt H and that thing goes away. In Teams, I don't know if you can hide it. Anybody? Do you know? Kindly put it in the chat window if you know. So here you can actually go to your function and then you can stop your function. And that is what I do as a good son, right? So when you run your Power App, kindly make sure that it is actually playing so that, your technicians, whoever have to run this, or the engineers who have to run this, know that it is working and so on and so forth, right? So I've given it, I've just said that right out loud. I mean, I don't know whether the engineers will notice this, but the whole idea right now is Power Apps for everybody, right? So if they actually see something like this as a warning, they know, there is this guy called Sanjeev, you need to call him so that he can turn on the function. I'm just joking, huh? So, over here, if I were to go up and actually say 104, this should actually run the first time. Let me see. This should run. Why is it not running? I have my function running. I have my, oh, yeah, that's the other thing, right? See, this is poka-yoke, right? Japanese say poka-yoke, foolproofing, make sure that everything, the obvious ones are there. So the foolproof over here is Dum Dum Sanjeev did this without actually the direction control, isn't it? I need to do the direction control, isn't it? Otherwise, it's not going to know what to do. So now if I do this, it should run. There you go. See? And now it's kind of instantaneous, isn't it? You see, it is actually capturing the time. The first one took 1.2 seconds. The second one took about 400 milliseconds. The third one is 600. Then the fourth one is 500. Then the fifth one is 475, so on and so forth. I'm going to stop this, right? So now we know that, the whole stack actually works in order for me to get my devices going. Now, let's understand this. Is this fast enough for my solution, right? Now, I will never be satisfied until I get my 16 milliseconds that you saw from my raw code to my device, right? I will never be satisfied. I'll keep doing this. I'll look high, low, Copilot. I'll say, Dhruvan, and he is one of the most handsomest people. Huh? So I'll say, Dhruvan, you're so handsome. I'll look at his, I'll look everywhere on earth to find, a solution to get us close. So why is that, right? So, we are living in the world right now where there are a lot of like devices around us, right? There are agricultural drones in India. I was in Bangalore the other day. I was, for my dad, he's 91, he's getting on. So I had to take him to the hospital for something. He's fine, I just had to take him there. And then I met with somebody over there who is a farmer because he had come for his father. And then he was telling me that, oh, we have tried drones and, we got into a conversation about drones and so on and so forth. The point is people are experimenting with it. People are trying it. They're trying it in warehouses. They're trying it outside. Firefighters are trying it. The Singapore Civil Defense Forces have got like drones and so on and so forth. There are robots. In that environment, you basically want to, control it remotely, right? So many of these gizmos are now controlled on-prem, right? So they will have a hardware controller very close by, close to the device, and they're controlling it, right? But if these speeds actually go down to even milliseconds like right now, hey, guess what? I can actually run a drone out in the field. No problem, right? I can run it from my Power App. and it'll actually work spectacularly, right? Obviously, I will have overrides and protection and so on and so forth, but it'll actually work. And the goal is to get to that nirvana state of instantaneous communication so that I can do whatever I want to do with the device, right? If you have the ideal state, if you want to, you can slow the speed. That is up to you, right? But to get to the ideal speed is your nirvana point. Everybody with me? So that kind of is the summary of this whole thing. And once I'm able to do this, then obviously you can do your copilot and so on and so forth, right? So as an example, if I were to go up here and go to my LinkedIn over here, where is this? If I go back here and then go to the post, so this guy is flying a drone. So instead of using C#, I'm actually using Python. So that was my next study to say if it takes about 500 milliseconds with C#, how much time does Python actually take? I would imagine it'll be maybe about 700 milliseconds to maybe a minute or something like that for the drone to run. That's what I've kind of observed. I've run the same drone using C#. It's much, much faster. So the point is, from here, I can actually take it to my Copilot Studio, right? I mean, Power Apps is one input. Copilot Studio is the same thing. So here, if I say start, I take that command, I pass it to my custom connector using Power Automate, and it does the rest. You follow me? So it doesn't matter the interface. For me, I still believe in an app because I'm a bit of a structured person. I don't like too much of open-ended conversations. So especially when it comes to technicians and so on and so forth, you don't want to waste their kind of time asking, how are you married, how many kids do you have? You just want to click that button, run the operation, get out. That's what you're paid for, right? So but I'm trying here, right? So I go in, I fly it, I take a picture of it, I store it on my SharePoint. Once I store it on my SharePoint, I actually pull it into my Power Automate, and then I have my ChatGPT prompt, from AI Builder. I pass it to the prompt, the image, and then I retrieve the result, and then I do something else with it, right? So as an example, if I were to, 2 seconds show you that, I think I should have my Python code somewhere here. So out here, basically, it has gone in, it is connected to the drone. It is actually like, a drone is a computer. That's about it, right? It's nothing different from this little device that you saw. And then once it reaches a particular height, it is actually sending it is connecting to SharePoint, and it's actually patching that image to SharePoint, right? And once the SharePoint, absorbs it, then basically you will have a Power Automate flow. So I might have the flow here, maybe not. Let me just see. My favorite office.com, and then we will go to Power Automate. 2 seconds, folk, and I'll stop here and let's open it up for questions. But then let me see in manufacturing. Okay, so if I go to my flows, and then I have my drone flow here, and then if I were to edit this, oh, it's odd that it says, I mean, I've run it before. It's odd that it says I haven't run it. Something's going on with this environment. That's something I need to check as well. So, instead of actually using IoT Hub, here I'm using Azure IoT Central. In Azure IoT Central, you can connect to the same device, and you can actually pass a command here. You see your device ID, device command, and then you can actually send in the pulses. Yeah, send in the pulses. Sorry, guys. So you can actually send in the pulses over here. So once I send the pulse, it basically picks up the file. When a file is created in the folder, right? It goes there, and then it gets the file's content. It initializes a variable, and then it passes it to the GPT, right? It's a prompt. Basically, it says, hey, when the tick mark is black, blah, 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 pointing to whatever, then you pick up that actual value, because it reads it over here. You pick up that actual value, and then you do whatever you want. You say, hey, I'm going to turn on a compressor, whatever you want to. So there'll be like a multiple agent scenario where one agent is flying the drone and then taking a picture. The other agent analyzes the picture and then does something, and the third agent maybe turns on an air compressor or something like that. And the reason why I did this particular one over here was, in many situations in everywhere across the world, it doesn't have to be anywhere in like Singapore or Indonesia or India. You will have, cases where you have analog gauges. So instead of replacing the whole gauge with new blah, 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 you can still retain the analog gauge, send a robot or a drone there, let it take a picture, we'll analyze it, it'll analyze it, it will actually turn things on so you can prevent the frontline worker from being in the harm's way. Just imagine like a steel industry or something like that. It's a harsh environment. So you prevent like human beings from being in that harsh environment by actually like, reading off of these drones. Does it work well? Absolutely. I'll show you what happened. So the first time I had not flown the drone all the way up. I was testing it, right? So it had just come up to this point over here. So it didn't read the meter, and the co-pilot basically, it read the it read the what do you call it? It read the bottom of the gauge, and it says, "I'm sorry, I don't actually see a black needle." Right? My wife was like, she is a lawyer. She doesn't like know half of these things. So she was standing right next to me, and she goes, "Hey, that's not too bad. That it came back to you and said, look, I'm sorry, you'll have to run the drone a little higher because I can't see the reading." Isn't that fantastic? So this actually works. Of course, you need to train it 1,000 times for it to go into production. But hey, this if the rest of AI works, this works well too. All it is like a mobile computer is all your drone is, right? So if your static computer can do this, I mean your mobile computer can do that as well. Of course, you need to take into account the mechanics of this. That is not trivial. I do admit it's not trivial. I mean, the code for that is hideous, and you need to do all kinds of testing and so on and so forth. Okay. But with this, I actually stop, folks. So let me hand it back to Abhinav and Dhruvin, and then I'll thank you very much for the kindness.
Thanks so much, Sanjeev, for this amazing session. I'll call it a cocktail of technologies, right? Blended right, mix to create the perfect brew. So amazing.
Thank you
Yeah,
very much.
the use cases are brilliant here. Just that, how do you manage to, work through all these myriad of technologies and come with a thought
So,
process around it?
so that's a good question, right? Yesterday I was actually talking to somebody who is in a casino
Mhm,
here. He's a senior director in a casino. He wanted
mhm.
to know what this Power Apps, blah, blah, blah was all about. So he took a course with me. And then
Wow.
he is an engineer. He's a controls engineer. So I walked
Uh-huh.
him through all this, and we were like laughing, because both in my 90s, when we
Mhm.
were doing the printed circuit board as it populates, your Raspberry Pi and things like
Uh-huh.
that, there is a camera that goes on it at the very end. So the camera
Okay.
goes on it, it sees the board, and it sees if there are any resistors missing or capacitors missing, and it flags it. This is from the, early 90s, mid 90s. You follow me? So
Mhm.
it is doing
Mhm.
AI then. I mean, of course, we didn't actually call it AI. We just call it some vision tech or something like that. And then here we are, when we like superimpose a form, and then pulls everything, and everybody
Mhm.
goes gaga, right? But the point is that he said, "Hey, look, I can actually like do this," because he builds robots and all that. He was like, I can, all I need is a code. Okay, I need a code to talk to the robot. Now I need the same code to run in Microsoft. How do I do that? Well, I need to package it in some kind of an app. What kind of an app could it be? Oh, there is something called as a function or a logic app. Function seems nice because
Mhm.
I can get access to the actual code. Okay, I'm running the code in Microsoft, but I have my Power App. Now my Power App needs to talk to that code. How do I do that? Hey, there is something called as a custom connector. There you go, right? So you literally talk. I literally talk, even in when I'm designing my solutions, I talk to it. I want to do this. Oh, okay, let's unpack that step by step, write it down, and then you find the nuggets, within Microsoft to actually like, and then you obviously have your co-pilot, like Clavin was saying. I just like dump the thought process. I have a starter code. I take my starter code, I throw it up there, and I ask it to say, hey, optimize this component, remove the logging component because I don't want to focus on it right now. So it removes that logger part, and it like simplifies the code. Then optimize this particular, you see, so if you spend like, let us say, half a day with it, I mean, you can have amazing things. I'm planning on getting started with quantum, with qubits right now, right? I mean, it's just like I told you, right? I'm 5 years old, right? I'm like my son who just came by. I don't care what people think or what opinions. I absolutely don't care. For me, it is the joy of actually being able to use a language. I mean, coding is nothing more than a language. So I'm able to use a language to bring my thoughts to reality. And you experiment with it. So that's the simple thought process of connecting all these things. For me, whether it's Power BI, whether it's like Azure Function or something, is meaningless. It's what it actually does behind the scenes
Mhm.
to help me is what it's all about, right? And then, of course, there are people like you, heroes there. I'm standing on the shoulders of giants, man. So, I look at all your blogs, look at like, learn from you. And that's why we have the community, right? I mean, it's such a beautiful community. I'm sure each one of you over here is doing amazing stuff. It's just that you don't like publish it, maybe. So, that's how you learn.
Yeah, thanks so much, Sanjay sir, for that. And this is, I'll say, this is called thought leadership. And then again, those
Oh my God.
inspiring words, right? Like looking at the larger picture, not just looking at the complexity of the technology, but what you actually want to achieve. Uh, Quoting your statements there. So
Right,
that's
right.
what that's what is inspiring, and I'd say that everyone should adopt from it.
Oh my God. Very kind
Not
words, sir.
yeah, the
Very
fear
kind
of
words.
technology that will help us
Yeah.
grow with the
Please,
innovations
please,
in technology that are happening, right?
very
So
kind words.
adopting to them.
The only
Being
feedback
hostile.
I ask, the only feedback I ask for is if you like the session, please comment on that post, the one where it's 550, and then say, how can we bring this to like, 0 milliseconds or something like that, so that it'll, spur a bunch of conversation amongst all the engineers as well. One
Mhm.
guy, one engineer came in and actually like, said it. He's, I think, the gentleman, if I'm not mistaken, who I spoke with yesterday. So likewise,
Mhm.
please go ahead, mark it, and then add some comments so that we can build on it, and maybe we can do a jam session one of these days, and then see what we can do. Okay,
Absolutely.
super.
Yeah.
I'll hand it back. We're up on time, I think.
Okay. Yeah.
Yeah,
Thanks so much for joining us over the weekend and imparting yet again another engaging session.
most welcome.
Thanking you and welcoming our next host,